For the last section, 7.5, we're going to look at the average value of a function. Suppose we want to compute the average temperature during the day if we have infinitely many readings. The diagram shows the graph of a temperature function t. Temperature of t, where little t is measured in hours and capital T is in Celsius degrees. And a guess at the average temperature, we'll call that T sub average. All right, so we're going to say, well, maybe this red line, whoops, come back here. Damn it, you mouse. All right, welcome to 7.5, the average value of a function. Suppose we want to compute the average temperature during the day if we have infinitely many readings. The diagram shows the graph of a temperature function, capital T of little t, where little t is measured in hours and capital T is measured in Celsius degrees. And we have a guess at what the average temperature will be, which is capital T of little AVE for average. That's our red line. Okay? So the way we do this is first you have to divide your time from A to B into n equal subintervals of width delta x. So that's to find the average of all these subintervals, you take b minus a divided by n, and that's going to be all of our subintervals. I think I said average, I meant to say subintervals. All right, next we'll choose any arbitrary x from each interval, and we'll calculate that so we can find the average. Now, a little trick what I need to do here. All right, we're going to take this delta x, which is b minus a over n. I need to solve it for n, so it's basically multiply the n over to here, divide by the change in x here. Because what I'm going to do is with this summation, all right, where I take my function value, any arbitrary function in my subinterval, and divide it by n, I want to replace that n with b minus a over the change in x. There's my substitution. But of course, we don't want to have a fraction in our denominator. We don't divide by fractions. We multiply by its reciprocal. So the change in x comes up to here. The b minus a stays in the denominator, or better yet, let's factor it to the front of the summation. And then we know, just like we've always done, to build your integral, you have to take the limit of this as your number of intervals n goes to infinity, and then that creates our integral formula for the average value of a function. So that'll be 1 over b minus a times our integral from a to b of f of x dx. So suppose we were asked to find the average value of f of x equals 2 times sine of x minus sine of 2x on the interval from 0 to pi. So with our formula, we need to go plug everything in. A is 0, b is pi. So 1 over pi minus 0, integrate from 0 to pi, of this function. All right, so that'll be 1 over pi. Now, if we integrate 2 sine of x, remember when you integrate sine of x, that's a negative cosine, so that'll be negative 2 cosine of x, minus, here we have sine of 2x. You have a function inside of a function. So if I use u substitution here, looking at just this part, let u be the 2x, and take the derivative of both sides. Du equals 2 times dx. Again, I'll have to divide over the 2 to solve for dx. So 1/2 times the integral of sine of u du. And when you integrate sine, like we said over here, it would be a negative cosine u multiplied by that 1/2. Take the 2x and put it back in for u. And so I have minus a negative minus the negative becomes plus 1/2 cosine of 2x. And again, we'll evaluate it from pi to 0. So let's substitute everything in. So 1 over pi, we have negative 2 cosine of pi plus 1/2 cosine of 2 pi minus the negative 2 cosine of 0 plus 1/2 cosine of 0. Just plugging in the pi's for the x's and then plugging in the zeros when we subtract them. So a little evaluation time, thinking about your unit circle here, cosine of pi, that's all the way over to the negative side for your x's, so that will be a negative 1. Cosine of 2 pi, that's a complete revolution, that's a positive 1. Cosine of 0 is the same as 2 pi, so that's a 1, and this is a 1. So I have a negative 2 times negative 1, which is 2, plus 1/2 times 1, that's a half. I have negative 2 times 1 is negative 2, but I'm going to distribute my negative and change it to a plus 2. And then a negative times the 1/2 times 1 is negative 1/2. The halves cancel. 2 plus 2 is 4. 4 over pi will be my average function value. All right, the mean value theorem of integrals says if f is continuous on a and b, then there exists a number c in our closed interval from a to b such that f of c equals our average value function. All right, and what we can do is we can take this 1 over b minus a and, if you will, multiply its reciprocal over to the other side and say now the integral from a to b of f of x dx is equal to this f of c times b minus a. So what that means is the following. There is some c value that if you create a rectangle based on this c giving you f of c as the height, which is your average function value, and you build that rectangle's area, that area is the same area on that interval that's underneath that blue curve. All right? So like I said, we just multiplied that over, and that's our height of our rectangle. B minus a, that's your width or length, or the base of your rectangle. So the area of the rectangle is the same as the area under the curve on our interval, our closed interval from a to b, which is above the x-axis.